Hello guys, welcome to Open Techno. Today we're checking out this device here on the channel, the Terramaster D8 Hybrid. And you might be wondering what it's for. Well, it's a device that will help us organize all our storage, music. It works in a similar way to what we all know as a network attached storage. However, we can't call it that because we don't have a network card to connect it and access the files inside directly from the internet. However, it works like a giant hard drive that we can connect directly to our computer. However, later I'll also tell you that we can use it, for example, to add capacity to a network attached storage, or for example, to make a network drive, but with the help of a small server, like a Raspberry Pi, for example. But before we get into how it works, let's take a quick look at the aesthetics of this device. This Terramaster D8 Hybrid measures about 22 centimeters long, then about 17 and about 15 for the front, both the width and the height. Well, it's a device, like all network attached storage units, with 4 bays. It's going to be a bit bigger than what a hard drive would take up, since on the top and the back, we're going to have a fan for cooling the drives. This fan would only produce 21 decibels of sound, which is practically inaudible. It's very quiet, but it gives us a bit of cooling for the drives if we're putting them under load. Then, we're going to have a weight of 1.9 kilograms. It's going to weigh a bit because of the entire plastic casing, the drive mounts, the board, the controller, and so on, so 1.9 kilos. It's a device typically placed on a table with rubber feet on the bottom, so that won't be a problem. Now, let's look at what else we can see on the front. We have 4 bays for hard drives, mechanical hard drives that can be either 3.5 or 2 inches, both hard disk drive and SSD. And then on this side, which I'll show you later, we'll have the possibility to add up to 4 M.2 non-volatile memory express drives through peripheral component interconnect express. How much storage can we get? In total, we'll be able to get up to 120 terabytes. That is, if we combine 422 terabytes mechanical drives in the front and then 4 8 terabytes, 8 drives, this would give us about 120 gigabytes of total storage that we can get in the back. You'll see that we have the power port, the USB 3.2 port, which we can connect to a computer to use it as a hard drive. We'll also be able to connect it to a network attached storage to expand the capacity of an existing network attached storage. Or, for example, will we be able to plug it into a small server to make ourselves a homemade network attached storage? How do fences work? I'll explain briefly now, and later we'll look at a practical example. We're going to have 4 fences on the front, 4 for M.2 on the side, and all the fences, let's start by saying, work individually. What does this mean? That if we put in 8 drives, once we connect it to the computer, we'll see 8 independent drives. But then, what's the point of this device? Well, mainly the presentation of these drives. We'll be able to put in 4 M.2s, 4 mechanical drives. Well, in a way, as you can see, it's quite aesthetic, plugging it directly into the computer. Although it's true that in slots 1 and 2, it will allow us to make some small adjustments. We'll have the function to see the drives separately, and we'll have the option to combine them with what he calls JBOD, which is basically joining them together. Each file would go to a drive randomly, then we'll have redundant array of independent disks 0, which is redundant array of independent disks 0. What it allows us to do is split the files between both drives, but it divides them. That is, half of a file can be on one drive and the other half on another, which allows us a much higher read speed. And finally, we would have redundant array of independent disks. What this basically does is duplicate the contents of one hard drive onto the other. In case either of them breaks down, you can take it out, put in a new one, and simplify it. Basically, a backup would be made automatically. Keep in mind that JBOD and RAID 0 simply add up the capacities for us. That is, 2 1 terabyte drives would make 2 terabytes, but RAID 1 keeps the same storage, simply replicating it on the other drive. Therefore, if we have 2 1 terabyte drives, the resulting capacity would also be 1 terabyte. I could tell you a lot more technical stuff, but just keep in mind that it's going to work with the main operating systems, Mac, Windows, Linux for Windows. It is true that we have a tool that slightly expands the functionality of this device. And then, just to let you know, it works with USB 3.2, it can be USB-C, but it's also compatible with Thunderbolt or USB 3.0, for example. However, the maximum bandwidth will be 10 gigabits per second. One last technical detail, the maximum power consumption of this device is 96 watts, although during normal operation it can use up to about 50 and around 10 watts. When we are in hibernation, that is, when the device is on but the drives are resting and nothing is being written to or read from the drives. But anyway, that being said, let's go see how this device works in practice. The first thing we're gonna do with this Terramaster is insert drives. And how do you do that? Well, there are two ways. First, by taking out these bays here, we're gonna have 4 bays, as you can see here. For HDDs or even SSDs, but they have to be this size, either 2.5 inches or 3.5 inches. And then on this side panel, we would have the 4 ports for M2 NVMe drives. In my case, I'm only going to use HDDs. I've had to gather several drives to be able to do this test. As you can see, here I have the first drive. This is a 500 gigabyte Hitachi drive, a small drive that came from an old laptop which I recovered, and it's going to go in the first bay. This is important. Second drive, we have another 500 gigabyte drive in this case, a bit bigger as you can already see. And in the third bay, we're also gonna have a large drive, but in this case, we're gonna have a Seagate with 1 terabyte of storage. In this last case, to show it fully, we'll remove what would be an empty bay, which as you see has no drive or anything else. We would simply remove these rails here and then put a drive in here, securing it with these rails you see here. If it's a small one, we would secure it with these 4 screws here. This will depend on the size of the drive, but it's not complicated at all, and you also get all the tools you need to install it. If we want to install drives on this side, how do we do it? It's simple. We have 2 screws on this back part here, one right in the top corner and another in the bottom corner. And once the screws are removed, we're gonna slide this small plate that we have here. And as you can see, this is what we have left. Here we have the 4 slots available for the M2 NVMe, which would give us higher speed. But as I mentioned, in my case, I'm not going to install this type of drives. I'm just going to install 2. In the first bays, which we'll use to set up a redundant array of independent disks to test what a redundant array of independent disks is. 1 drive will be on its own, and well, the rest of the 5 bays will remain empty. And now many of you might be wondering why I'm turning it. Well, I'm turning it so you can see this selector we have here. This selector, it comes with a small tool, a very small screwdriver, which we'll use to select the mode in which bays 1 and 2 on the front, that is, the hard disk drives, will operate. Well, we're going to have 4 modes. We'll have the single mode or solo mode, however you want to call it, which allows us to have each of the network attached storage drives completely separate. That is, the computer would recognize all of them as individual drives. However, if we turn this up and set it to JBOZ, what we're going to achieve is that disks 1 and 2 will be combined. Whether they have 500 gigabytes, 1 terabyte, or 1.5 terabytes, they'll be unified into a single drive with the total size. However, it's important to understand this option. What this will do is split the files between the 2 disks, so we might find a complete file on one disk and another complete file on the other disk. What's the difference with a redundant array of independent disks 0, which many of you might be wondering about? Well, there are actually very few differences. Redundant array of independent disks 0 is the next option we have, and what redundant array of independent disks 0 does is even split the files across different disks. That means the same file might have half of it on one disk and the other half on another, which would give us much higher speed. As I said, these 2 modes are very similar, but with redundant array of independent disks 0, if we lose a disk, we're going to lose all the data, while with just a bunch of disks, we'll have less speed. But if we lose one disk, it doesn't mean we've lost all the files we had stored. Lastly, what do we want? Redundancy? Then we set it to redundant array of independent disks on What it would do is, so to speak, make a duplicate of one disk onto another. That way, if one disk fails, the second one would be fully operational. We just put in a new disk and it would clone the data again, so nothing is lost. As I said, redundant array of independent disks 1 is the safest because we will have redundancy. However, both the VALA 3-4 and all the NVMEs that will go on this side will operate in single mode, that is, completely on their own. Once we've chosen the mode we want for fences 1 and 2, we just use this pin to press the reset button. So, hold it for 5 seconds until the front LEDs light up red or until the computer detects us. The new configuration we've set for the drives is now done. Be very careful with this reset because it formats the hard drives. And well, since we're at the back panel now, let me show you that here we have the power port and the USB-C 3.2, which we would connect to our computer with the native cable that comes with it to maximize speed. And here's the best part, we power on our network attached storage from the back panel. And now, as you can see, the 3 drives are going to appear on the computer screen. I've also named them Disk 1, Disk 2, and Disk 3 according to the order of the slots we have. Also, you'll see a drive called AL6 terabytes, which is my drive where I store absolutely all the videos from the channel. As you can see, I've formatted each one of them. We have 500 gigabytes on disk, 500 gigabytes on disk 2, and 1 terabytes on disk 3. Exactly as I explained to you in the previous clip. Now, what would I like to do? Well, we're gonna do 2 tests. I've downloaded Disk Speed Test, which is a program that allows us to write to and read from a hard drive. That way we can check the speed of each one. For example, I'm going to do it with disk 1 and 2 separately. I select them, tell it for example to write 5 terabytes, and then I hit start. As you can see, this first disk has about 40 megabytes of write speed. And as for the read speed, well, we have almost double that, about 75 megabytes of read speed. Let's do the test again with disk 2 for example. We would click start. In this case, disk 2 for example is a larger hard drive and spins faster, so it has slightly better speed. So we have 85 megabytes of writing and about 85 megabytes of writing as well. And well, finally, we have disk 3, which as I mentioned will always work on its own. So to do a test, for example, with this disk 3, I would simply copy the 10 gigabytes of videos I have here, and you'll see that it will take less than a minute. Here it shows us it's already at 1.5 gigabytes. Anyway, it's going pretty fast. Now, what am I gonna do? I'm gonna mount the first the two 500 terabytes ones in a redundant array of independent disks 0, which in principle is going to give us much more speed for that. Although you won't see it, all I'm gonna do is change the indicator I showed you on the back until I have redundant array of independent disks 0, and I'm going to hold the reset button for 5 seconds. As you can see, in about a minute, it has already copied these 10 gigabytes of videos to disk 3. Okay, I've already held the reset button for 5 seconds. So the first 2 disks, disk 1 and the one you're seeing, have already disappeared from here. Why? Because right now the network attached storage itself has combined them into a single one. And what the computer is telling me is that it doesn't recognize it. What do I want to do? Well, I'm gonna go to the disk utility and I'll see that there's a new 1 terabytes disk here. And I'm simply gonna click erase. I'm gonna name it combined disk and I'll give it, well, an Apple file system format and click erase. So that way it formats it for me. Mac tells me, for example, if I want to use this new disk to make a time machine backup, we could do that perfectly. We would, for example, select the combined disk here, set a password, give it a short name, and well, we can also set a usage limit. If we want to encrypt the backup, in my case, I'm not going to make a backup right now. As you can see, it gives me all the disks to use. And the best thing would be, if we want to make backups, to set up a redundant array of independent disks, one to give more security to what we have on each of the disks. Although the resulting capacity would be 500 gigabytes, not 1 terabytes, which would be the sum of both. Since what I want is speed, I set up a redundant array of independent disks 0, which the network attached storage manages automatically for me. So now, if we go back to our speed testing application and I select this new combined disk, it should give us much more speed than before. Before, if you remember, it gave us 40 and 80 megabytes per second for writing. We start the test again, and as you can see, the write speed of that disk now is 140 megabytes per second. Just like the read speed, it would also be about 150 megabytes per second approximately. And remember that before it took us about a minute to copy around 10 gigabytes to disk 3, so let's see how long it takes to copy it to this redundant array of independent disks 0. Let's do the same test. And as you can see, it's already finishing copying all the files. However, did you also notice that it took about a minute? Why? Well, basically, if we had done this before, it probably would have taken about twice or 3 times as long to copy. But why did it take the same amount of time as on disk 3? Well, because if we test disk 3, it's a much higher quality disk. And as you can see, it's already giving me speeds of 180, even 190 megabytes per second for writing and reading. So, well, this way we would have increased. Did you see it in the test we ran earlier on the combined disk? We would have increased that speed, which was stuck at 40 or 80 megabytes per second, up to 140. We would have improved the speed a lot. Imagine if we put in 2 drives like the one we have in Bay 3, which is already very fast, and combine them in redundant array of independent disks 0, then they would go twice as fast. Of course, if you want security, I recommend redundant array of independent disks 1. Although you would lose some speed, of course, you would end up with a much lower speed. And now many of you might also be wondering if the Thunderbolt 3 port Thunderbolt 4, USB 3.2, whatever you want to call it, can handle all the load we can put on it with several drives at the same time. Well, I'm gonna do a test. For example, I'm gonna load things onto the combined drive and onto drive 3 separately. Alright, we start copying here, which is gonna take a little longer, and now here, at the same time, you'll see that we have, well, 2 copies that are gonna take us about a minute. So the bandwidth that the cable, the computer, and the network attached storage itself can handle is going to be no problem. The same goes for the hard drives. Right now, I don't know the bandwidth of one of these cables, but just so you know, it's more than enough to work with all the drives at the same time. Now, some of you might be wondering if this storage, this network attached storage, makes a lot of noise. Well, I have it right now on the table. Obviously, what we hear the most are each of the mechanical drives we have working here. But also, this network attached storage has a fan at the back, and that fan is completely inaudible. So you can hear the noise it makes. I'll be quiet and move the microphone closer to this network attached storage. I don't think you can hear anything at all. Like I said, it's very quiet, but if it bothers you, you could turn it down. For example, you could put it under the table, on the floor, or somewhere you can't see it. And with that said, I just have to ask you, what do you think about this device? You were probably thinking it was a network attached storage, that we could connect it to our router with a network card, share content, and so on. No, this is simply storage organization. We'll be able to set up a small redundant array of independent disks with bays 1 and 2, but it's just for organizing our storage. So all that's left is to discuss the price and ask, what do you think? The price of this device is about 280 euros right now on Amazon, although you might find some deals. At the moment, the price is 280 euros. If you have questions, leave them in the comments and we'll answer as soon as we can. If you liked it, give us a like. With that said, I hope you enjoyed the video and I'll see you in the next one. Goodbye.